In the last year, one video game company has taken an innovative step towards a new interactive style of gameplay, the Nintendo Wii. But it's the Wii's controller, the Wii Remote, or Wiimote, that's changing the industry. The Wiimote uses a combination of motion sensing technology as well as a pointer system to create a level of interactivity in games that was previously impossible. But how does it work? Inside the Wiimote, there is a speaker and audio amplifier chip. These allow for audible feedback from right inside the remote. There's also a standard memory chip, capable of storing up to 16 kilobytes of information. The most coveted chip inside of the Wii Remote is the accelerometer. This records the direction and strength of forces being applied on the Wii Remote. The data converter then converts these analog forces into digital data that can be sent to the Wii via Bluetooth. The directions the accelerometer can detect include front to back, or the Z-axis, side to side, or the X-axis, and up and down, or Y-axis. It uses these three forces to calculate exactly what direction a force applied to it is traveling. It can also detect bank and pitch. To find the pitch, it finds the force of gravity, which is always pointing down, and compares it with the angle it makes with the Wiimote. If the angle is acute, then it knows the Wiimote is tilting downward. If the angle is obtuse, then it knows the Wiimote is tilting upwards. The same applies to the bank. It measures the angle of gravity versus the Wii Remote and calculates its tilt. By combining these two values, we see how the Wiimote knows exactly which way it's being tilted. On the other side of the remote, we find a rumble pack. This creates physical vibrations in the remote that correspond with an event on the screen. The large chip in the center is a Bluetooth chip that's responsible for transferring information to and from the Wiimote and the Wii. The Wiimote has a chip for translating analog data, such as human speech, into a digital data stream. Basically, it acts as a microphone. On the bottom, there's a port for plugging in controller attachments. The entire system is powered by two AA batteries. Finally, there is an infrared sensor used to detect and translate signals sent to it by the sensor bar. Oddly enough, the sensor bar doesn't actually sense anything. Instead, it has two sets of 5 infrared lights that the Wiimote uses to triangulate its location on the screen. Because of the infrared filter on the front of the Wiimote, all it can see are the 10 lights from the sensor bar. When the lights from the sensor bar move to the bottom of its view, it knows that the cursor should be at the top of the screen. When the lights are on the top of the view, the cursor is placed at the bottom of the screen. The same applies to left and right motion. By reversing the angle created by the lights, the remote can display a slanted cursor on the screen. The innovation of the Wii Remote has changed how we play games forever, and helped make the Nintendo Wii a legend in its own time.